All right, we're going to start off by going over the essential questions. Essential question 1, what can an electrically neutral object, how can it become charged, even though a charge cannot be created or destroyed? So remember, you can't produce something, you can't take something away because science says that that's not possible. So an electrically neutral object can only become charged if it loses a charge to another object or gains a charge from another object. So they have to be able to transfer the charges. So it doesn't become created, it's not destroyed, it doesn't go away. It's just transferred from one object to another. Essential question number 2, what is the difference between charging by contact or charging by induction? So these are two things that we discussed when we were doing the balloon activity. Charging by contact refers to the transfer of electrons by means of direct contact. So in process, a body with one type of charge produces the same type of charge on a conductor. Now, charging by induction refers to the movement of electrons to one part of an object by the electric field of an object. So in this process, the opposite type of charge is produced. So basically, charging by contact is when we were rubbing the balloon on our head, and charging by induction is how we were getting the balloon to move across the table, even though we were not touching. All right, the second section is over an electric current. So a voltage difference causes electrons to flow in a circuit. How does voltage difference cause a current to flow? Essential question number 4, what are the factors that affect an electrical resistance? Okay, so first off, an electric current is the total movement of an electric charge in a single direction. Electrons are in constant motion in all directions, so there's really no net movement. When electric current flows, electrons are continuously moving randomly, but also drift in the direction that the electric current flows. For example, a ball bouncing down the stairs. A ball is bouncing, going up and down. However, it's also going in the direction of the stairs. So if you see, it's constant motion up and down as it moves down the stairs, but it's also moving down the stairs. A voltage difference is related to the force that causes electric charges to flow. Electric current is measured in volts. So like we've talked about, a 9-volt battery. This would be an example of a closed circuit. We did a little example in class over a closed circuit. You can see on the right-hand side how we have one part of the wire attached to the positive end of the battery, and then we have the light bulb, which is called the resistor, and then we have another wire that's going to the negative end of the battery. So this is closed because the wire is continuously creating this full loop with no gaps in between. A battery can provide the voltage difference that is needed to keep current flowing in a circuit. So it's necessary to have some sort of power source, and what we're going to be working on is working with batteries. A current flows, like I said, as long as the path is closed. If we were to open up one of the terminals to the battery, then obviously the light bulb would not glow. Electric motors are specifically there to run on either an alternating current or a direct current. A battery is a device which produces a continual direct current through a chemical reaction that's found inside of the battery. Now, obviously, a little AAA battery isn't going to be quite as potent as what you're going to find as a car battery. A car battery's chemical reaction that's happening inside is much, much stronger than what it would be for a AAA battery. Therefore, it's able to operate a larger vehicle. Batteries can be composed of a liquid electrolyte. If it's a liquid on the inside, it's called a wet cell battery. If it's a paste on the inside, it's called a dry cell battery. Both car and boat batteries are examples of wet cell batteries. A flashlight would have a dry cell battery. There is a chemical reaction inside the battery that pulls the electrons away from one of the terminals and gives them to the other. This causes one terminal to be negative and the other to be positive. When these terminals are connected through a device like a wire, they're able to power the device. So this kind of shows, if you look down the middle, we have the carbon positive electrode that's going through. That is the conductor on the inside. And then surrounding that conductor, you see a paste. And then of course a separator that helps to make the battery safe to touch. And then when you take a wire or a conductor of some sort and you put it on the positive and the negative end of this battery, it's able to light the light bulb. The light bulb would be, again, called a resistor. Okay, so a resistor is a material that slows the flow of electricity. So that light bulb is put there so that it's slowing the flow of electricity so that it can actually go to the light bulb and light it up. Almost all materials, even good conductors, provide at least a small amount of resistance, so it's trying to slow the flow of electricity. Resistance is the tendency of a material to oppose the flow of electrons, changing the electrical energy into thermal energy and light. So that light bulb is trying to take that electrical energy that's running through the wires and turning it into light energy, but also if you touch the light bulb, it's thermal energy as well. Resistors are measured in ohms. The symbol at the bottom is the symbol for a resistor. Simple circuit contains a source of voltage difference, which would be a battery, a device that has resistance, like a light bulb, and a conductor that connects the device to the battery terminals, which would be like a wire. So again, remember, the battery is what we say is the voltage difference. This is what is producing the energy. A resistor is like the light bulb that we would hook up to our simple circuit, and then the conductor would be the wires. If the voltage difference doesn't change, so again, if the battery doesn't change, decreasing the resistance increases the current in the circuit. So if I put 5 light bulbs together, connected to this same 9-volt battery, these light bulbs are not going to be very bright. However, if I only plug in 1 light bulb to that battery, it's going to be pretty darn bright. So if I increase the amount of resistance, it's decreasing the amount of voltage difference that's going to each of these light bulbs because it has to be divided amongst the 5 light bulbs that are plugged in. If resistance doesn't change, increasing the voltage difference increases the current. All right, so a direct current is when you have the current flowing in one direction. So for example, a battery would be a direct current. It's only flowing through the battery in one direction. Lightning, it's only flowing from the cloud down. Static electricity, it's only flowing out from the source. So it's not going there and back. Lightning is a form of direct current produced by static electricity in the clouds. We've kind of talked about this a little bit. The static is formed when the air molecules move past each other, just like your clothes in the dryer. That negative charge group at the bottom of the cloud and transfer electrons to the ground, which has taken on the positive charge. So you can see in the image we have the negative charge in the clouds and the lightning, but then we have positively charged particles on the ground. So why do you think the ground has taken on a positive charge? Does lightning always travel from the cloud to the ground? You know, that has been a common misconception that a lot of people would like to know the answer to. Now, tendency, there has to be some sort of attraction between the negative charge in the clouds and a positive charge on the ground. So, yes. Now, we talked about direct current. An alternating current will send a flow of electrons in one direction through a circuit, and then it will reverse the flow in the other direction. Household outlets are an example of this. They reverse the direction of the current about 120 times per second. Now, this is what makes them safe, is being able to do this. Because if they were a direct current, then you have a lot of electricity flowing to each of these outlets. Now, Ohm's law. Ohm's law is that relationship between your battery, the current, the wire, and the light bulb that we have created in this simple circuit. So we can actually measure this in terms of mathematical equation. A current, which is measured in amperes. We take the voltage difference, which again is the battery, and divide it by resistance, which is in ohms. Okay, so again, I want you guys to put this in your ISN. right underneath the notes on page 40. So what is the voltage difference in a circuit with a resistance of 25 ohms if the current is 0.5 amperes? Okay, so again, let's flip back. The current, which is in amperes, equals the voltage difference divided by resistance in ohms. Okay, so if we're trying to find the voltage difference, what we need to do, we are going to set up 0.5 amperes equals, we're looking for the voltage difference, divided by 25 ohms. Okay, so to solve this, I need to multiply by 25 on each side. So I'm going to take my 0.5, multiply by 25 to get the voltage difference. So 0.5 times 25 equals 12.5. And voltage difference is measured in volts. Okay, so like a 9-volt battery. All right, number 2. We're going to calculate the resistance of a current of 0.5 amperes with flows in a 60-watt light bulb when the voltage difference between the ends of the filament is 120 volts. Okay, so this one's a little bit different. Okay, so I still have my amps of 0.5 set it equal to, okay, so this time they're giving me my resistance, 120 volts, divided by, I am looking for resistance. Okay, so this time we would multiply by resistance on both sides. So it would be 0.5 R equals 120. Now to get the resistance, I need to divide both sides by 0.5, so 120 divided by 0.5 equals 240 ohms is what we were looking for. Okay, so the big point out of this section is to really understand the formula. Okay, so current in amperes equals the voltage difference, which is the battery source, divided by resistance in ohms. Resistance, again, is the light bulbs or something that is taking the flow of electricity and slowing it down. Generally, it's a light source or a heat source. All right, so that concludes the podcast. I would like you to try the even problems on the Ohm's Law worksheet, which are problems that are just like this.